Good morning. This is Bruce Mitchell from the Parts Super Center. I'd like to welcome those of you who are on the call. We're going to be talking about DC Contactor Specifics. I hope the call is interesting to you. We'll be running about a half hour for the presentation, and then we'll be taking questions for the last 15 minutes or so. Again, I hope this meeting is of interest. I'm going to try and cover a fairly wide range of subjects having to do with DC contactors, from general information to some very specific information. If you have any questions, feel free to put those in, and we will try and address them at the 11:30 hour. As I said, I'm going to try and cover a wide range of subjects having to do with DC contactors. I hope you find it interesting. I will try and not get too detailed to go over anybody's heads, and I'm going to try and start us with basics and then move up in complexity. I'd like to first start out with some general housekeeping information. I want everybody to know that we will be recording this webinar for future purposes, and it will be placed on our site at the website that is given there, Parts Super Center Homes/resources. And again, if you have any questions during the presentation, feel free to insert your questions in the question and answer session on the right-hand side of the screen. To give you a little more information, those of you who are not familiar with the Parts Super Center regional sales structure, we have 5 regional salespeople located around the country. In the North Atlantic, we have Christopher Olson, phone number and an email address. In the Midwest, we have Fred Kantner, again, his phone number and email address. In the Southeast, Paul Zucchino, covering that territory, phone number, email address. In the Gulf area, we have Rosemary Abramson and her phone number and email, and Justin Sandlin on the West Coast. So if you have any questions following up this presentation, or you would like to speak to one of our regional salespeople, feel free to contact them. I will be showing the same slide again at the end of the presentation. So if you didn't get a chance to copy down any of this information, you can catch it at the end of the presentation, or you can go to our website and it will also be there. Okay, just a short overview of what we're going to be talking about today. I'm sure you're all familiar with AC contactors. 3-pole, 480 volt type devices. They are not in the presentation today, and we will not be talking about basically any AC devices today, but we will be having another webinar in the future where we'll be talking about AC devices. So that's in the future. What we will be talking about today are DC contactors. And basically, at a very high level, DC contactors can either be 1 normally open or 2 normally open power poles, or 1 normally closed power pole, primarily for applications of dynamic braking, 1 normally open and 1 normally closed power pole, which is primarily for reversing the rotation of a DC motor. Then you can have contactors that are 2 normally open and 1 normally closed. And these are more special purpose and include the normally closed contactor for dynamic braking. Just to get back to an earlier point, a 1 normally open power pole is generally on the high side of a DC bus. If you've got a 2 normally open power pole device, you're braking both sides of the DC bus. So that's the difference between an application for a single normally open versus a 2 normally open. As far as operating voltage for DC devices, commonly you have 120, 240, 480, 600, and this is called the 600 volt DC class of devices. but you do have devices in applications of 750, 1000 volt DC and higher, and these are more in special purpose, not in the normal industrial kind of applications. Then you also have lower operating voltages, 24, 48, 72, and 96 volt DC. Again, these are more in the electric vehicle control and special purpose applications. And then you also have, as far as DC contactor types, the AC operated DC contactors. And these again are for special purpose applications. And we'll talk about those in a little more detail in a few more slides. Okay, I always like to start off with a little definition of some AC and DC devices. I know to a lot of you this is very basic, but we sometimes get inquiries where terminology is somewhat interchanged, and I always like to run this slide just to get people all on the same page. Basically, a switch is a manually operated full load device of any particular current or amperage rating. For example, we're all familiar with light switches. So that's a switch. It's a manually operated full load device. A contactor, however, is an electrically operated power switching device designed for multiple operations. So you can have current ratings from anywhere from 10 amps to above 4,000 amps. But a contactor, again, is multiple operations, where the breaker, the next item down, is generally considered to be a high power or a fault interrupting devices with relatively few operations. Now, there are some where it's used multiple times a day, but breakers are generally considered to be fault interruption or high power interruption devices. And then a relay is basically an electrically operated control device, generally with a current rating of about 10 amps. And its function is to provide status information to either some other device or something in the control circuit. So just high level, kind of some general definitions. Okay, when we talk about contactor ratings, and these apply specifically to DC that we're talking about today, but are also applicable for AC. We have, sorry, jumped ahead of myself. We have the NEMA rating, and to give you a little background, NEMA, National Electrical Manufacturers Association, established these ratings back in the 1950s. And basically the NEMA devices I would call heavy duty application, very general. They run in current ratings from 10 amps, which would be a size 0, up through 2550 amps, which is size 9. And again, AC and DC also have these same kind of ratings. On the other side, we have what I call IEC, which is the European type devices, where their ratings and applications are very specific to a specific device that they're using. So you can see ratings such as 10 amps, 25 amps, and then where NEMA would have, for example, a 40 amp or a 50 amp device for a NEMA size, you might have a 40, 50, 60, or even an 80 amp IEC rating. And as you can see from the tables, the ratings and families are not always one for one, but generally you think of the NEMA device as being a heavy duty, where the IEC device is more application specific. Again, speaking generalities here, not going to get into any specific details, but just to kind of show you how NEMA devices relate to IEC devices. Okay, on DC contactors, there's basically 5 different forms that are commonly used. The one normally open where you're breaking just one pole of the DC circuit, 2 normally open where you're breaking both the positive and negative side of the DC circuit. Then you have the 1 normally open and 1 normally closed variety, which is primarily for reversing, 1 normally closed, which is dynamic braking. And then you have a 2 normally open, 1 normally closed, which is special purpose or frequently used in drive contactors or synchronous motor field contactors and some other similar type applications. We talked about dynamic braking, and I know that term may not be familiar to everybody, but basically a dynamic braking contactor is one normally closed pole, and these are special, I will use the term high make capability to allow for high DC motor discharge currents to be dissipated, generally into a resistor bank or something similar, during a normal or emergency stop. So dynamic braking contactors have a different application than the normal DC contactor. I mentioned drive special purpose contactors. These are basically two normally open, one normally closed power pole. In this particular instance, this is an AC operated DC contact, and this is very common for these drive special purpose devices. These devices are basically an AC contactor, i.e. it has an AC coil, but it has a DC rating, and one pole is converted on the 3-pole contactor from normally open to normally closed. So you have a 2 normally open, 1 normally closed power pole. And again, these are frequently found in a lot of package drives and small drive applications. Give you a little bit of background on the GE family of contactors and some terminology. You find a lot of this in the field. GE had several families of devices back from the 1950, 1960 time period. We had the 2800, basically the 1600 series, which were referred to as general purpose DC contactors, and had ratings of 25, 50, and 100 amps. GE also made the 2800Y series, the Y100, Y101, 2, 3, 4, 5, 6, 7, and 8, which were considered mill duty device, heavy duty. Largest application was in places like steel mills back in the 1960s, 70s, and 80s time frame. GE also made a version of that device which they called the 1100 series, 1170, 1172, 74, 76, as shown, and these were back connected devices. And we'll talk a little bit more about that and show you a slide of what those devices look like. Today's versions, which replace virtually all of these, is the DS303 A1 and then a letter behind it, but basically you go from 25 amps up to 900 amps. So these earlier GE devices are replaced by today's DS303 devices. Okay, just to give you a little more information on how these two devices relate to one another. The DS303 contactor, which is the one that is provided today, has a very unique feature in that it has a completely enclosed arc within an enclosed arc chute. Unlike the IC2800, the earlier family, and most competitive contactors where the arc is actually thrown out into the environment, on the 303, the arc is completely contained within the arc chute. A couple of comments that we frequently get. As far as mounting space, generally the 303s, when they replace the IC2800 family of devices, fit inside the footprint of the older IC2800. Wiring and mounting are basically the same. The interlocks used on the 303 and the IC2800 is the exact same, so that if you have the 2800 and you have spare parts, those spare parts can be frequently used on the 303 family of products. As far as parts availability, the IC2800 family, most common wear parts being things like coils, tips, springs, and certain other parts are still available, and they can be found in the Renewal Parts publication, which we refer to as GEFs, like in Frank. And all that information is also available on the Parts Supercenter website. And on the 303, which is the current product, all parts are still available, and there are Renewal Parts publications and Parts Supercenter website. And if you're interested in getting these GEF publications, you can also contact your regional sales leaders, and they can help you with that. Bear with me, we've got a little technical problem here, okay. Looking at some DC contactor configurations, I just want to give you kind of a visual. We have the normal contactor here being the size 1 through size 3, kind of has this appearance. Here is what we call a normally open, normally closed, sometimes referred to as a broken back contactor. And then in larger frame sizes, the size 4, 5, and 6, and 7 have this appearance, but basically they're all basically the same device. Another device which I want to mention, which is a DC contactor, and you may hear people talk about the so-called big red for obvious reasons, a lot of red in it. It is a special purpose contactor designed by GE, a very high interrupting capability, a high voltage rating well above the nominal 600 volts. This device is basic to many GE drive and control products and is used in special drive applications. Again, the picture shows it laying down. It's rotated 90 degrees in the actual application. Typical installation for the DC contactors, as I mentioned, heavy in places like steel mills, paper mills, cranes, overhead cranes, material handling. Also find applications in things like rapid transit, locomotives, battery banks, and a lot of special applications, and just a few pictures here of what those typical installations look like. To give you a visual indication of what some of these contactors look like when they're actually mounted, on the left-hand side is a panel from an overhead crane showing multiple DC contactors, some disconnects, some overloads, and some other things. And then on the right-hand side, and I love this picture, this is what they call dead front panel from a steel mill application. Again, these are the old IC 2800 contactors with the very large arc chute that expend the arc out into the atmosphere. On the lower corner here is a DS303 replacement, and here's another one here, of those IC 2800 contactors. So you can see how the footprint of the DS303 is smaller generally than the related IC 2800 device. And again, this is a dead front. And when I was talking about back connected, these devices are all back connected, meaning that there are holes in this panel that go back through the panel. The device is mounted from the back, and all the wiring is behind the panel, with the exception of this wiring up here. But all these devices are what we call back connected. The replacement device is, of course, front connected. But this gives you a kind of a visual idea of what these DC contactors look like when they are installed. Okay, I mentioned in our introduction low voltage contactors, basically anything below 96 volts, large usage in electric vehicles. Basically, the contactor is the same as the 600 volt contactor, except it doesn't have a blowout coil, doesn't have arc chute, which are significant parts of it. So it's much smaller in size and rating. And basically with a low voltage contactor, all you're really getting is a coil, contacts, and the terminals. So it's a much smaller device. Again, low voltage, so it doesn't have the blowout coils and the arc chutes. Now, I mentioned blowout coils. And I think that this is a good way to illustrate the makeup of a DC contactor. There's a lot of detail here, and I'll just kind of walk through. Again, this illustration here is a back-connected version, but you have the arc chute, the blowout coil, the stationary and movable contacts, the compression spring, then you have the operating coil and a hinged armature here that operates the movable contacts. And again, in this device, these would be the mounting screws for a back connected device. And here you have your power buses. Again, just to show you in a little more simplified version, you have your blowout coil, your movable and stationary contact tips, the armature spring, the coil, and the core, and then your incoming terminal and your outgoing terminal. Again, just to kind of help you visualize what a contactor look like. Now, this happens to be pictures of the old IC 2800 type contactor, but I think it gives you a good visual indication of what a contactor is made out of. Now, one of the reasons I wanted to also pull this up, we talked about the blowout coil, and that's another question that we frequently get: what, why, and what's a blowout coil, and why the difference in a blowout coil on an AC and DC device. On an AC power circuit, you have a 60 cycle wave here, and you have 3 points during this cycle: point A, point B, and point C, when the voltage is actually 0. So it becomes relatively easy to interrupt the arc because the line voltage is going to 0 60 times a second. So it's relatively easier to interrupt the alternating current than it is direct current. With direct current, and just as a reference here, direct current, if you have 120 volt AC, the direct current is 60 volts DC. Well, if you've got a 480 volt or a 600 volt DC bus, that DC bus is very high and it never goes to 0. So you actually have to, quote, blow the arc out when you have an interrupting during a normal operation. And to give you a little more detail, and again, we're getting a little more into detail on the DC contactor operation, but I think it's helpful just to understand some of the parts and pieces. Here is a partial circuit of a DC contactor. You have your incoming line coming up, going through the tips, the stationary and movable tips. And this shows it in the tips opening. And you see an arc here, which is going from the 2 tips. Now the current flows through this part of it, which is called the blowout coil. And the blowout coil actually creates a magnetic field, as shown here, and pushes this arc out into the arc chute. So from whence you get the term blowout, it's literally blowing the arc out magnetically into the arc chute and extinguishing the arc and, opening up the DC circuit. To give you an idea what a blowout coil looked like, here would be a blowout coil that was made of wire. Could be anything from a very small 12 to a number 8. When you get into bigger currents, here is an arc chute made out of ribbon and just a single bar or complementary. So this is what an arc chute, this is what a blowout coil looks like. And you will find a lot of reference in DC devices to the blowout rating. And the blowout rating has to do with the force that is established here when you're actually interrupting the arc. Again, to go into that same picture again that we talked about before, the DC contactor with the blowout coil, the stationary and movable tips. This configuration, this is the old IC 2800 version. This is what that DC contactor looks like, the DS303 again with the coil, the operating coil, movable and stationary tips. You have your blowout coil here, and this is the arc chute that totally contains the arc. So this is the earlier version, the IC2800. This is the DS303 version. Okay, question has come up on renewal parts on either the DS303 or the IC2800. All of our devices, all DC devices, have a renewal parts publication, which we refer to as GEF, that are available virtually on all of our DC contactors and the DC relays. Now, I talked about DC relays, for example, and I wanted to just take a minute to mention DC relays, which go by the nomenclature of an IC2820. Notice these are control, not power devices. The interlocks are generally rated at 10 amps, and they can either be a single auxiliary circuit or multiple. We have some of our DC relays that have 10 or 12 auxiliary circuits. And in the way of information, the interlock that's used on the power contactors, the IC2800s or the DS303s, are the same relay interlocks that are used on the 2820s. So you have common renewal parts between the DC relays and the DC contactors. Okay, speaking of DC relays, excuse me, there are special purpose DC relays, things like overload relays, under voltage relays, synchronous motor field relays, another lot of special purpose DC relays, some of which are obsolete, many of which are still available. But in addition to just doing auxiliaries, some of them are very special purpose devices. And now, excuse me, I need to take a drink here. Good news for all of you who have been uncomfortable with the shipping cycles on these devices. As you know, we ran into some issues with some of our vendors. The DC device shipment cycles now have been virtually cut in half and will probably be reduced in the future to even lower. And if you do have any issues or problems, feel free to contact your regional sales leader to talk about improvement of shipping cycles. But it's good news, and always like to finish a presentation with good news. As far as additional information, I've shown here what we call the rainbow catalog. On this side, rainbow, of course, for the different colors on the comments. It includes DC contactors and DC relays, a lot of what I have already talked about today. But in addition, it also includes information on mill duty AC and DC brakes, mill duty limit switches, number of mill duty resistors, also includes information on grounding resistors and other products. And this is available both electronic copy and hard copy. And you can contact your regional sales leaders if you would like to get copies of these. And as I mentioned early on, and I'm just going to kind of go back through that in case you did have questions or issues that you would like to bring up. Here are our 5 regional sales leaders, and I'll leave that up on the presentation for a minute. So if you have questions and you want to know who to contact from the Parts Super Center, these are our regional sales leaders, both telephone and email addresses. And I'll leave that up for a minute if anybody needs to copy any information down. Then moving on to just kind of a review. In the past, the Parts Super Center has done webinars on other products that we handle through our business, things like transformers, on the Magnum Blast breakers, recommended service advisory letters, troubleshooting on GE oil circuit breakers, DC motor maintenance and troubleshooting, design and applications of vertical AC motors, and GE vapor transformers, replacement parts and such. And all of these webinars can be viewed at the site that's shown, pscparts.com. That's the site for the Parts Supercenter, and under the resources category. Again, I'd like to thank you for your interest. Thank you for listening to me for the last half hour or so. Hope that this has been educational. We're now going to open up the forum for anybody that has questions. Certainly try and take any questions that are asked. We've allocated 15 minutes. If we don't have those questions, we will finish up in less than 15 minutes, but feel free to have those questions forwarded to us.
Perfect. Thank you, Bruce. So we have one question. Our first question is, what does it mean when a contactor is said to have suppression?
Okay, thank you. That's a very, very good question. Back in the day, back in the 60s and 70s, when a DC contactor opens, the coil being highly inductive would tend to put a high voltage spike back in the control circuit. And in order to protect the devices that were also in that control circuit, they would put what's called suppression on the coil, basically a resistor capacitor network that was attached to the device. So you would have a DC contactor with suppression would have this resistor capacitor mounted to basically the bottom of the device. And when that happens, the coil number on the contactor is changed to reflect that it does have suppression. Generally, the coil number then would start with like a 500 series. But again, the purpose was to suppress that. With today's technology, they have other ways of doing suppression, but that was very common back in the 50s, 60s, and 70s.
Perfect. Thank you so much, Bruce. Our next question is, are the same interlocks used on both DS303 DC contactors and on IC2820 type DC relays?
Thank you. Yes, as I mentioned, yeah, the same interlock block has been used on both the IC2800 devices and the DS303s for the last number of years, so that yes, the renewal parts for the interlocks for both devices and the DC relays are all the same. So you've got a universal replacement part for all three of those kind of devices.
Perfect, thank you. And then the final question that we have, and if anybody has any additional questions, please feel free to put it in the questions toolbar. The final question that we have is, can the interlock contact form, normally open or normally closed, be changed in the field?
Yes, excellent, thank you. Very good question. Yes, the interlock blocks that are supplied as far as the devices are concerned are basically three different forms. You can have an interlock block with two normally open, you can have an interlock block with two normally closed, or you can have an interlock block with one normally open, one normally closed. The configuration can easily be changed in the field in just virtually a couple of minutes by removing a couple of E-rings and changing the contacts. So virtually a two normally open, two normally closed, or one normally open, one normally closed interlock block can be easily changed in the field to another configuration. So if you have one and need it with a different contactor configuration or interlock configuration, that can easily be done. And there is documentation available to just show how it's taken care of. And again, it's less than a 5-minute process.
Wonderful, thank you, Bruce. We actually had a few additional questions come in.
Sure.
How does the footprint of the DC 303 compare to that of the Simmons ABB or other competitors' contactors?
Very good question. Again, as I mentioned, there are at least 9 different frame sizes going all the way from a 25 amp to a 2500 amp. The footprints are going to be similar, but because of the possible differences of 1 normally open pole, 2 normally open, 1 normally open, can't give you a specific question. But if you have a question on a specific relationship between a 303 and a competitor's device, we'll be happy to actually look into that and get back to you with specifics based upon, again, the current rating, the number of poles, and the specific device. But yes, we'll be happy to try and respond to that question with as much detail as may be needed.
Thanks, Bruce. The next question that we have is, what factory location does GE make these DC contactors in? Are they stocked?
Okay, good. Very good question. As far as the product manufacturing location, the plants have moved as GE, as you are all well aware, has gone through a number of organizational changes. The location where these devices have been made over the past 10 to 15 years have moved considerably from originally at several plants in Puerto Rico, back in the United States, and a couple of places in the United States. These devices are all now made at the Parts Supercenter facility in Indianapolis, Indiana. We have a complete manufacturing facility there. As far as stock, yes, as I mentioned earlier, our cycle times are being cut in half and being cut in half again. And we are planning on actually carrying a large number of devices in stock. We just have to clean up the backlog, which we're working on right now. And we hope to be in stock situations within the next several months. Again, we're trying to clean up all the back orders that were left over. But our plan is to carry the common versions in stock, and then specials with either having different interlock configurations or having different voltage coils or other things. We plan on being able to convert the stock device into a special requirement within a short working period. So the goal is to stock the common versions and then do last minute modification to take care of any special needs. And again, your regional, if you have questions on that, you can contact your regional sales leader who can give you more specific details on specific sizes or ratings. But again, a very, very good question.
Wonderful. Thanks so much, Bruce. And this looks like our final question. DS303 is a direct replacement for the DC2800? Question mark. How is the price comparison between the two and connecting and mounting?
Okay, good. Another good question. Yes, basically all of the IC2800 devices, which, just to give you a time frame, were originally designed back in the 50s, have been superseded and are no longer available with a few limited exceptions. So the only product that is currently manufactured is the DS303 with a few minor exceptions. As far as pricing, before the conversion and the obsolescence of the IC2800 families, these were very comparable. Again, being a large number of NEMA sizes and different pole configurations can't give you a specific one-on-one. And what was the second part of that question, please?
The second part of the question is, how is the price comparison between the two and connections and mounting?
Oh, connections and mounting. Thank you. Yes, All the connections, both the power connections, the positive and negative buses and power connections and interlocks are all exactly the same. Again, the interlock blocks on both devices are exactly the same, so all the connections, the interlock are the same. Physical location of the interlock on the IC2800 is very close to the physical location of the interlock on the DS303. All the wiring would be the same. The only difference is, and I mentioned earlier, on certain of the IC2800, the 1100 series, which were back connected, they are replaced by the DS303s, which are front connected. And again, as far as mounting space, generally, the DS303 footprint would be smaller than the footprint of the IC2800 device. There may be a few exceptions, but generally the 303 is going to be a smaller footprint and definitely would have a smaller space available, because on the DS303 you have a totally enclosed arc within the arc chute, whereas on the IC2800 you had to leave space in front of the device for the arc to come out of the arc chute. That's not required. So in general, the 303s, and again, if you have specific questions on the mounting dimensions for a 303, those are all in our publications. And we do have outline drawings on all the DS303s. So if you're interested in knowing what the footprint and the mounting hole locations would be on the 303s, those are readily available.
Perfect. Thank you, Bruce. And we actually just had one last question come in, and this will be our last question that we'll address during the webinar. If we have any additional questions, we'll go ahead and just contact you after. The last question is, are limit amp contact kits still available for the 400 and 700A contactors?
Okay, all right. Okay, we're switching over. Yeah, and that's fine. You're switching over from DC over to AC. Limit amp is the 2400, 4160, 7200 volt AC high voltage device. Those are still available with of course limitations. Again, the limit amp product line, the GE limit amp product line, which is now the ABB limit amp product line, goes back from the 1960s. Believe it or not, I still worked in a factory in the 1960s. There are a lot of variations of different kinds and ratings. So we would need to get into specifics on the specific device that you're looking for, the 200 amp or the 400 amp. But yes, in general, there are parts and pieces available. Again, we'd have to get into the specifics on the exact limit amp contactor that you're asking about. Again, thank you all for participating and listening. We certainly appreciate your time. I know it is valuable, and we appreciate your sharing this time with us.
Thank you, everyone. And I will go ahead and send a recorded version to everyone who attended the webinar today if you're interested in sharing it with your colleagues. Thanks, everyone.